Learning goal 24 is going to be all about solving one-step linear equations. When it's all said and done, we're looking at solving linear equations, but we're going to be taking a look at just the single step. So we're going to be taking a look at one step at this point. We're not going to go into multi-step at this point. We'll get into that a little bit later. But first, we're going to take a look at what are linear equations. And so we're going to do a little bit of background as to what they are. A linear equation is a function in math which has a large number of solutions. And so solutions, and this all depends on the input that comes from there. So the number of solutions all depend on what is being inputted into the equation. So think about in many cases, we could represent something where depending on what I give you, your response might be different. Okay? And that would be what a linear equation looks like. Linear equations use variables, okay, to represent a value which could change, okay, depending on the situation. Okay? These functions are used in many places where the result is dependent on the input given. So the result that we get is based on the input. Okay, so if you're going to input a certain number, the result will be something else. And then if we change the number, the result will be different, or often the result will be different. Now, a linear equation is made up of two variables. Okay, we often use x and y, and for this particular lesson, I will just be using x and y, and so that will hopefully help to make things a little bit simpler, but they can totally change depending on the situation. Okay, so the linear equation is made up of two variables whose values are not constants. Again, they change. That's the whole term variable. If one variable changes, okay, the other one will change as well. So in a linear equation, okay, if we change one value, we're going to change, the second value is going to change as well. So think about it as, let's just use an example. Let's imagine we're going to the store and you're going to buy a whole bunch of candy. Okay? The price that you pay is all dependent on how much candy you get. Okay? If you get a pound of candy, it's going to cost something. If you get 2 pounds, it's going to cost more, usually twice as much. Okay? That is what we're looking at. When one value changes, the other one will as well. For every value of x, there's going to be a matching, okay, or related y value. Okay, so there's a matching y value or a related y value that is associated with each value of x. These will be determined by the linear function or by the linear equation that we are given. Now, just going to look at one right here. This is the most basic one. We have y equals x. Okay, so the y value is equal to the x. This is the most basic of linear equations. And to solve for either x or y, okay, the other variable needs to be known. If we want to solve for a specific variable, we need to know what the other one is. Okay, so if let's say we are told that y equals 6. Okay, so let's say that we're told y equals 6. If we know that y equals 6, then the y value of the equation can be replaced with 6. Okay, the y value can be replaced with 6, and the value of x can be found. Okay, so you'll notice here what I did is I took this equation that we have and I replaced the y value with 6. So now all of a sudden it says 6 is equal to x. And so it tells us that actually x is equal to 6 as well. Okay, so if I would pick a value for x, I could plug it in for x, and then I would know what y equals. Okay, that's what a linear function does. for every value of y, we're going to have a value of x, okay? And they're going to be related to each other. In this case, they're going to be exactly the same, but that's not necessarily the case every single time. So in this case it is, but it's not necessarily the case every single time. Okay? Now, a linear equation can also be can often be thought of as a problem which needs to be solved using several steps. Okay, so a problem that needs to be solved using several steps. The number of steps changes based on the equation. Today, we're going to be looking at ones that only have one step. Okay, so only one step. In later lessons, we're going to be looking at ones that have multiple steps. As with many problems, both math and non-math related, sometimes the solution is known. Slide that up. And the beginning value needs to be solved for. Okay, so sometimes we already know the solution and we want to find the beginning value. So then we would have to work through our steps backwards. Okay, and we're going to be doing a lot of that today. We're going to be looking at how do we work through our steps backwards. Okay, so the solution is already known, but we want to find everything else. So something like this here, we have something plus 25 equals to 47. Well, we know that our solution in this case is 47. We want to find what is that beginning value. What's going to be added to 25 to create 47? Okay, that's what we're looking for. Now, in this example that we have here, the final answer of 47 is known, but one of the numbers that's being added is unknown. Okay, and we can think of this as the variable. Now, normally I say we have two variables. One of the variables is always going to be given. So this would be our equation here, x plus 25 equals y. So y is already given. We're already told that y is 47. Now we want to try to figure out what is x. Well, that would be the case at least here. So if you do this here, you can probably kind of, based on some prior knowledge, you can probably understand that this is 22. Okay, 22 plus 25 equals 47. So that's just kind of using our background knowledge here. So if we're doing this here, what it would be given the equation to determine the value of y when x is 13. Again, this goes back to linear equations. What we would do is we'd plug 13 in for x. So this would then be 13 plus 25 is equal to y. And we could figure out what y was. And in this case here, it would be 38 because we add the two together to get. So then in this case, y equals 38. And so that's a pair there. So we know that when x is 13, y has to be 38. We can also do it if we're given a y value. And I'm just going to make this into an equation here. So then if we have a y, we're going to then replace the y with 40. And then we need to figure out what value of x would make that work. And in this case here, okay, it's going to be x is equal to 15, because if we add 15 to 25, it's going to work. Now again, this expression is a linear equation. Each value of x is going to have a unique value of y. So you notice that when x is 13, y is 38. When x is 15, y is 40. We have a very unique solution for each question. Okay, so each question or each value of x has a unique value of y, the same way that each value of y has that same unique value of x.